following video will cover basic setup and operation of the oscilloscope featured in the electronics labs at Western Washington University. The video is intended for students in Etec 351 that are using the oscilloscope for their lab experiments. The oscilloscope hooks into a circuit that is being tested on the breadboard or any other electrical system in order to test the voltages and the waveforms of the given circuit. It does this by displaying the graph of your tested circuit on the screen of the oscilloscope. The screen shows the graph of voltage over time. To begin operation of the oscilloscope, you must first start by turning it on. In order to turn it on, you must press the power button that is located in the bottom left-hand corner of the oscilloscope control panel. Upon startup, if the oscilloscope screen is not in its default mode, on the upper right-hand corner of the oscilloscope control panel, there is a default setting button. Press the default setting button to return the oscilloscope to its default settings and to begin operation of the oscilloscope. The oscilloscope in the Etec lab has one output and two inputs. The output, or general output, is located on the left-hand side of the oscilloscope. The two inputs, labeled 1 and 2, are located on the bottom right-hand portion of the oscilloscope. Like all electrical systems, a closed circuit is needed for there to be current flow through the oscilloscope. WWU has a few types of probes that can be used to complete the circuit. There is the standard probe, alligator clips, and magnetic field sensors. Primarily for Etec lab experiments, you'll be using standard probe. After you have selected the probes that you would like to use, you can connect them to the oscilloscope by using their respective terminals below. One must be connected to the general output to act as the ground for the oscilloscope. Your other probes will be connected to the input terminals located on the bottom right-hand portion of the oscilloscope. To activate these input terminals, you must first press the button located just above them, labeled 1 and 2. After the terminals have been activated, you can adjust the vertical scale using the knob above the activation button for the terminal to adjust the voltage scale. The knob below adjusts the position of your output graph. This way, you can stagger the graphs to give you a better image of two different input waves. After these portions have been fine-tuned, you can adjust the horizontal scale of the input graphs using the horizontal knob on the top of the control panel. The trigger is a setting that gives you the ability to capture one frame in the oscilloscope. Pressing the trigger button will allow you to set options at the bottom of the screen. You have the option to capture the wave when it's on an edge rise, an edge fall, either, or both. The knob located in the trigger selection menu will set the limit of the trigger. it is best to think of the trigger as if the graph is rising above the trigger voltage, then capture the graph. Setting the trigger higher than the graph will be able to reach will cause the trigger not to stop and for the graph to constantly be in motion. Once the graph is triggered, you'll be able to measure the voltage, the period, and the phase shift of one or multiple graphs. In order to use the WaveGen function, you must first connect the ground to input 1 and activate it. Next we have the wave generator function. To turn on the WaveGen, you must first press the WaveGen button located in the middle of the control panel. Once it is activated, you can use the buttons below the screen to adjust the waveform. Once the waveform is selected, you can use the knob located to the left of the WaveGen button to adjust the vertical scale of the WaveGen. Also, the horizontal knob can be adjusted to adjust the horizontal scale of the wave generated by the WaveGen function. Once you are done using the oscilloscope, you must simply unplug all probes connected to the terminals and press the power button to turn it off.